This is the review for quiz number 3 about the sum, difference, double, and half angle identities. To help you with this, you're going to need your formula sheet, and you might also need a calculator, but it does not need to be a scientific calculator. Anything should work. So to start off, they want us to draw and fill in triangle A. So it tells me that triangle A needs to be between pi over 2, which is here, and pi. So that makes triangle A in the second quadrant. And you can even see that on your formula sheet. Here's pi over 2, here's pi. So we're going to draw the triangle that looks like this. And on your formula sheet, you should have written down that this is the adjacent side, and it will be negative. This is the opposite side, it is positive, and this is the hypotenuse, which is always positive. Now, above where it tells me to fill in the triangle, it tells me that sine A is 3 over 5. Now, sine, from SO in the SOHCAHTOA, sine is opposite over hypotenuse. So the 3 is the opposite, and the 5 is the hypotenuse. And you might remember that 3, 4, and 5 always go together, or you can use the Pythagorean theorem to figure out what this third side of the triangle is going to be. So that's a squared plus b squared equals c squared. C is always the hypotenuse, and then A and B are just the opposite and adjacent sides. I would subtract 9 from both sides, and you get a squared equals 16, and when you take the square root, that is 4. Don't forget that there's this little negative sign in front of your 4. Now we need to draw and fill in triangle B. Triangle B is between 0 and pi over 2. So here's 0, here's pi over 2, which means the triangle's in quadrant 1. So you should draw it just like the triangle on your reference sheet. And also on your reference sheet, you should have written down that this is the adjacent side, it's positive. The opposite side is also positive, and the hypotenuse is positive. That's because everything in the first quadrant is positive. Now we know cosine is adjacent over hypotenuse. That comes from the CH. Oh, you can't see, sorry. That comes from the CH in the SOHCAHTOA. So 5 is my adjacent, 13 is my hypotenuse. And you will probably need to use the Pythagorean theorem to figure out the opposite side. So we have a squared plus b squared equals c squared. A is 5, and c is the hypotenuse is 13. So this is 25 plus b squared equals 169. Subtract 25 on both sides. B squared is 144. Take the square root is 12. So the opposite side is a positive 12. So now I've filled out my triangles. I have all 3 sides for each triangle, and that will make doing the problems below a little bit easier. So for number 3, it says to find the sine of a minus b. So you come down into your sum and difference formulas, the sine of a minus b, and I'm going to copy this formula right here. Sine a cosine b minus cosine a sine b. Now we're going to fill in the values. So I'm going to put some parentheses here, so that way I don't forget that I'm going to multiply these. Now every time it says an A, I'm going to use triangle A. So if it says to find the sine of A, sine is opposite over hypotenuse. So I'm going to do 3 over 5, and I'm going to fill that in under sine of A. Then it asks for cosine of B. Cosine is adjacent over hypotenuse, so you're going to do triangle B, adjacent 5 over hypotenuse 13. Cosine A is adjacent over hypotenuse, but use triangle A. So -4 over 5. And sine B comes from triangle B. Sine is opposite over hypotenuse, so 12 over 13. Now when you're dealing with fractions and you're multiplying, you have to multiply the top by the top and the bottom by the bottom. So 3 times 5 is 15. 5 times 13 is 65. And I'm going to be subtracting. -4 times 12 is -48. 5 times 13 is 65. Now, when you have fractions that have the same denominator, you keep that denominator when you're adding or subtracting. And you're going to do 15 minus a -48, which is really like 15 plus 48. It's 63. So this answer is 63 over 65. To find the cosine of 2b, you're going to look down here in my double angle identities. I'm finding one of the cosine of 2x. There are 3 formulas to choose from, and I think the first one's the easiest. So I'm going to do cosine squared x minus sine squared x. Now in this case, we're using triangle B. So you can replace the x's with a b. So this could be cosine squared b minus sine squared b. That means I'm only using triangle B. So whatever cosine of b is, we're going to square it and subtract whatever the sine of b is and square it. So cosine of b, cosine is adjacent over hypotenuse, so 5 over 13. Sine of b is opposite over hypotenuse, so that's 12 over 13. Now before you subtract, you have to square both of them. When you square a fraction, you square the top and you square the bottom. So I'm going to do 5 squared is 25. 13 squared is 169. Minus 12 squared is 144. 13 squared is 169. Now remember, when you're adding or subtracting fractions, they have to have the same denominator. So I'm going to have 169 as the denominator. Then I'm going to do 25 minus 144. And that is negative 119. So that's my answer. To find the sine of 2a, so I'm finding the sine of 2x formula, it's 2 sine x cosine x. But the problem said to use triangle A, so if you want, you can replace the x's with the a. So it's going to be 2 sine A cosine A. As you can see in this one, I'm only dealing with triangle A. So I'm going to multiply 2 times whatever the sine of A is times whatever the cosine of A is. So the sine of A, sine of triangle A, is opposite over hypotenuse. The cosine of A is the adjacent over the hypotenuse. Now we are just multiplying fractions here, so we multiply straight across. You're going to do 2 times 3 times negative 4. That's negative 24. 2 is in the top, is in the numerator, because this is technically 2 over 1. Then you're going to do 1 times 5 is 25. Now we have to do the cosine of b divided by 2. So I'm looking for the formula cosine x divided by 2, which is down here in the half angle identities. So I'm going to rewrite that formula real quick. Because I'm using b, I'm going to go ahead and replace the x's with b's. So this one is only using triangle B. So what is the cosine of B? Cosine is adjacent over hypotenuse, so it's 5 over 13. Then we have divided by 2. To solve this problem, or to simplify it, you're going to take whatever the denominator is here, and you're going to change that, change the 1 to be 13 over 13, or whatever that denominator is. Then you're going to squish the top together, or combine the numerators. 13 plus 5 is 18 over 13, then divided by 2. Now remember what we do when we have something in the denominator? We are going to flip it. So it's secretly over 1. You multiply by the reciprocal. So this becomes plus or minus the square root of 18 times 1 is 18. 13 times 2 is 26. The last step to this problem is to decide whether it's a positive or negative. So if you look, B is in the first quadrant. The first quadrant is always positive, so you're going to just go ahead and circle the positive one. Now to work on the back, it says to use the sum or different formulas to find cosine of 15. So the sum and difference formulas are right here in the middle. I need to find the cosine of 15. So I either need to add two things together on the unit circle to get to 15 or subtract them. So if I look, I can do 60 minus 45 to get 15, or 45 minus 30. You could also do 135 minus 120. But if possible, I like to try to stick to the first quadrant. So I'm going to do 45 minus 30. So I'm going to rewrite cosine of 15 as cosine of 45 minus 30, because 45 minus 30 equals 15. Now this is a cosine of A minus B formula, because I'm subtracting. So this is going to be cosine A, cosine B, plus sine A, sine B. And we're going to fill in what the cosine of A is, what B is, sine of A, and the sine of B. Now the cosine of A is 45. Let me go ahead and fill those in. We said B is 30, A is 45, B is 30. We're going to use our unit circle. So what is the cosine of 45? Well, cosine, it tells us, is the x-coordinate. It tells us it right down here in this box. So what is the x-coordinate at 45 degrees? Well, it's the square root of 2 over 2. Cosine again is the x-coordinate. What is the x-coordinate at 30 degrees? Square root 3 over 2. Now sine is the y-coordinate. It tells you right at the bottom here. So what is the y-coordinate? The y-coordinate at 45 degrees, square root 2 over 2. And the y-coordinate at 30 degrees is 1/2. So we need to multiply before we can add. So square root of 2 times square root of 3 is square root of 6. 2 times 2 is 4. Plus square root of 2 times 1 is square root of 2. 2 times 2 is 4. And they have the same denominator, so we're just going to squish them together. So we have the top is square root of 6 plus square root of 2 over 4. And that's your final answer. Now I want to use the sum or difference formulas to find the tangent of 105. So I want to find two things that add or subtract to 105 on the unit circle. So we could do could do 225 minus 120 is 105. Or we could have done 60 plus 45. That also equals 105. Either would be okay. I'm going to stick with this one then. So I'm doing a tangent something minus something. So a tangent A minus B. So I'm going to use this formula down here, tangent A minus B. Now we said A is 225 and B is 120. Remember that as you're going around the unit circle, that tangent is inside the boxes. So what is the tangent of 225? So 225 is here. The tangent is 1. So replace tangent of 225 with the number 1. Then we have minus. What is the tangent of 120? Is negative square root 3 over 2. Or sorry, just negative square root of 3. Then I have 1 plus. Tangent of 225, we already said is 1. Times tangent of 120 is negative square root 3. And then your last step is just to simplify this. If I have minus a negative, that becomes a plus. And in the denominator, I have 1 plus, what is 1 times negative square root of 3? It's just negative square root of 3. So I'm going to have 1 minus square root of 3. Now we need to use the half angle formula to find the sine of 75. So half angle identities are in the bottom right hand corner of your formula sheet. So I'm going to write down the formula. Now the first step, you need to take this sine of 75, you need to multiply it by 2, and that number replaces x. So 75 times 2 is 150. Then what is the cosine of 150? You look on your unit circle, cosine is the x-coordinate. So what is the x-coordinate at 150 degrees? It's 1/2. No, sorry. It's negative square root 3 over 2. So whatever the denominator is here, that's what we replace the 1 with. So it's going to be 2 over 2. What is 2 minus negative square root 3? Well, that's 2 plus square root 3. The denominator is 2, and the denominator under that is 2. Now when we have a denominator, we take what's in the denominator and we multiply by the reciprocal. So this secretly has an over 1, so I'm going to be multiplying by 1/2. Now 2 plus square root of 3 times 1 is just 2 plus square root 3. 2 times 2 is 4. And the last step is just to say that 75 is in the first quadrant, where everything is positive. So we are just going to want the positive square root of 2 plus square root of 3 over 4. Now to verify an identity, that's where you draw the line and you try to make this side equal the other side. So I have a cosine of something plus something. So that's a cosine of A plus B. So I'm going to write down that formula. Cosine A plus B is this one here. Now, all the A's are actually X's, and all the B's are pi over 2. So we don't know what the cosine of X is, so just leave that be. What is cosine of pi over 2? So what is the X coordinate at pi over 2? Well, it's 0. We don't know what the sine of X is, so just leave that alone. What is the sine, or the Y coordinate at pi over 2? Well, it's 1. Anything times 0 makes 0. And then negative sine X times 1 is just negative sine X. So we have gone from one side to the other side, so it's verified. Now the very last type of problems, those are problems that we were calling the go backwards problems. So I need to look in the sum or difference identity section, and I want to look at, well, what goes sine cosine plus cosine sine? So sine cosine plus cosine sine, that is the sine of A plus B formula. A, see A is the first number here. A is 80, B is 15. What is 80 plus 15? Well, that's 95. So to go backwards, this is breaking up the sine of 95. The last condensing problem goes cosine cosine plus sine sine. So look on here in this box. Which one goes cosine cosine plus sine sine? Well, it's this fourth one, the cosine A minus B. A is the first number, so that's 370. B is the second number, it's 105. what is 370 minus 105? It's 265, so this is asking what, well, this is the condensed form. It's the cosine of 265.